Everyone please confirm that am I audible, am I visible clearly to all of you? Audio video is clear to everyone, please confirm in the chat box. Everyone do confirm in the chat box, am I audible, am I visible clearly to all of you? Audio video is clear to everyone. Good evening Pooja, good evening. But please confirm, am I audible, am I visible clearly to all of you? Please confirm in the chat box, am I audible, am I visible clearly to all of you? Audio and video is clear, very good. How are you all? How are you all? So I hope you all are good and preparing well for your exam. And in the last class, we have covered the topic that was the plane table surveying. So we have discussed in detail about the plane table surveying. We have discussed about the various methods, accessories, advantage, disadvantage, all the topics we have covered. And I hope that discussion is clear to everyone. So everyone please confirm in the chat box the discussion related to the plane table surveying is clear to all of you. So I hope that discussion is clear to everyone. Okay, so now we are going to discuss a very simple topic, and that is the calculation of area and volume. Actually, this topic is not directly related to the surveying, but there will be the application of this topic. So we will have discussion what are the various methods that are available me and why we are covering this topic in this surveying course. So sir, we already know how we can calculate the area and how we can calculate the volume. I hope you all know how to calculate the area and how to calculate the volume. Sir, please say where we use traverse method. Wherever it is required. Wherever it is required. So for example, there may be a situation like this. So let's say somewhere here, let's say this is the building block. This is the building block. Somewhere here, let's say there is a tree. Somewhere here, let's say there is a tree. And somewhere here, let's say there is a water body. This is the water body. Some more detail is there. Here one is building block is there. Yes or no? And let's say one more building block is there. Something like this. Now in this situation, if you want to collect the data and if you want to collect the map, so you can go for the traverse method and also final method example, sir. First understand this point. So what I have done, I have decided that I will apply the traversing. So I have drawn, let's say for example, this is the point A. I have drawn a traverse something like this. Sorry. I have drawn a traverse something like this, and with the help of this traverse I am locating all these detail. With the help of this traverse or with the help of the offset I am locating these detail. So let me change the color. So let's say this is the situation. So what method we have applied here? What method we have applied here for the collection of the data? So this was the traversing. So where it will totally depend upon the suitability. So you can go for the triangulation, you can go for the traversing, yes or no? Any method, you can go for the trigonometrical surveying. So this is the example so that you can relate how we will collect the data with the help of the traversing. The point is clear? So that data, that traversing, that information you can also collect with the help of the plane table survey, as we have already discussed in the case of traverse survey. In the case of traverse survey, majorly there are two types of the measurements are required. One is the linear measurement, one is the angular measurement. So if you are anytime if you are going for the traverse survey, you should have one instrument from which you can measure the angle, and you should have one instrument from which you can measure the distance. Here we have done the traversing with the help of the plane table survey. Traversing we have also done with the help of the compass. Traversing we can do with the help of the theodolite. So traverse survey is a method. For that we can use the various instruments. And for if I talk about the resection method, as I can see your comment, so resection method I have already taken an example. So for example, if we are having an existing map, old map, and over the period of time, if there is some change, some more features are added, some features are eliminated. So if you want to modify that map, so we will modify that map, we can modify that map with the help of the resection method. But before the modification on that map, we require to identify the station where we have placed the plane table at the time of the preparation of the old map. So proper station we have to locate and proper orientation should be there. Then only we can update the existing map. Whether if I'm talking about the radiation method, intersection method, not resection, radiation, intersection, and traversing method, we were plotting this detail on the paper. We were collecting the data related to these detail, yes or no. That was the difference. Here we are not interested to find out the position of the plane table. So with the help of the resection method, with the help of the radiation method, with the help of traversing method, we were interested to plot the detail of the features. So that's why we have said that the first method having the first three method having the same objective, and fourth method, that was the resection, that is having the different objective. So you can locate the position of the plane table, you can find out the plane table station with the help of the two well-defined point. Well-defined point means that 2 points should be available on the ground, as well as that 2 points should be available on the existing map. So if we are locating the position of the plane table with the help of two known points, that problem was considered as the 2-point problem. Similarly, if there are 3 points are there whose are defined on the ground, whose are existing on the ground, as well as they are also available on the previous map. So if with the help of the three well-defined points we are locating or defining the position of the plane table, that will be considered as the 3-point problem. So this was the discussion related to the method of the plane table. I hope the discussion is clear to everyone. So if your doubt is clear, please confirm in the chat box so that we can proceed further. Everyone confirm in the chat box if the discussion till now is clear to everyone. Can we proceed further? Okay, very good. Can we proceed further now? So now the next topic that we are going to cover, that is the calculation of area and volume. I hope you all can calculate area and volume. You all know how to calculate the area and how to calculate the volume, yes or no? So for example, if this is the geometry, if let's say this is the A point, B point, C point, D point. So can you calculate the area of this geometry? Tell me. Can you calculate the area of this geometry? So as I can see, this is the rectangle. As I can say, this is the rectangle. So for that, I require this distance. Let's say this is going to be L, and this distance is going to be B. If we know the value of L and B, so simply we can say the area is going to be L into B. Yes or no? We can simply say the area is going to be L into B. So how you will know what will be the value of L and what will be the value of B? Here we require the base, we should have the basic understanding. Can I say AB? Can I say AB or L is nothing but it is the linear measurement? Similarly, if I talk about the BC or B, you can say it is also a linear measurement. It is also a linear measurement. Yes or no? And these linear measurements, or you can say the measurements related to the distances, for that you should have basic understanding of the surveying, and that we have already developed. Now we know. Now we know how we can measure the distance between the 2 points. Now we know how we can measure the horizontal distance. We have also discussed how we can measure the vertical distance. Similarly, how we can measure the horizontal angle and vertical angle. All these measurements we have already performed till now. So for that, surveying is required. To perform these linear measurements, angular measurements, you should have the understanding of the concept of the surveying, and that we have already covered. But we have calculated this area. Similarly, for there is one more geometry. Let's say there is one more geometry, and let's say this is the square of having the side A. Again, you can easily calculate the area, yes or no? Again, you can easily calculate the area for this square. What will be the area? So simply you are going to say, sir, area will be equal to A square. Area will be equal to A square. So but if I talk about irregular geometry, so for example, this is the geometry like this. For example, there is a geometry like this. Now tell me what will be the area. Now tell me what will be the area. Now you will have definitely have some problem. Yes or no? For the calculation of this area, you are definitely going to have some problem. What is the problem? Sir, this is not a regular geometry. Sir, if you will provide me the regular geometry, then I can easily calculate the area, yes or no? But as you can say, sir, this is the irregular geometry. So for that we don't have direct methods. For that we don't have direct methods like this. In the case of rectangle or in the case of square, we have calculated the area. Same approach we cannot follow for the irregular geometry. Yes or no? Similarly, if I talk about the volume, so volume I can write this will be equal to L into B into H, or you can say area into H is going to be the volume. Yes or no? So for regular geometry, there is no problem to calculate the area or to calculate the volume. Problem will arises when the feature is having the irregular geometry. When the feature is having the irregular geometry, so it is not necessary. In the case of surveying work, your feature is always having the regular geometry. Can you say that, sir, we will always have the regular geometry in our surveying work? Yes or no? So here it comes to understand, here it is very important to understand how we can calculate the area, how we can calculate the volume for the irregular geometry. Is there any method? Is there any method for the calculation of the area, for the calculation of the volume for the irregular geometry? So in this chapter, we are going to discuss about those methods only. I hope you got the basic why we are here to discuss about this chapter. This point is clear to everyone. Why we are discussing this chapter, this point is clear to everyone. So for regular geometry, we all are familiar how to calculate the area and volume, and for the calculation of area and volume, we require some measurement, and that measurement we can perform with the help of the surveying. With the help of the surveying. So I hope this point is clear to everyone. So yes, there are some methods. Obviously, we will talk about some approximate method. Obviously, for irregular geometry, it will be comparatively difficult to find out the exact area or exact volume. Yes or no? For irregular geometry, there will be difficulty to measure the exact area and exact volume. So various methods are there, and we will try to use the most appropriate or most accurate method from which we can calculate the exact or approximately correct area and volume. So now we will discuss one by one. Now we will discuss all the methods one by one. It is very small, simple chapter. 4 formulas are there that we need to discuss. And yes, from this chapter you are frequently getting, especially in your case, in the case of your GATE exam or in the case of your ESE exam, you are frequently getting the question from these topics. So just understand very basic discussion. So what are the various methods for the area calculation that we will discuss, and what are the various methods for the volume calculation that we will discuss. Let's see. So if I talk about the area, so first method that we are going to discuss, that is by dividing the area into the number of triangles. By dividing the area into the number of triangles. So for example, this was any feature. This was any feature for which you need to calculate the area. Obviously, as you can see, this is not a regular geometry. This is not a regular geometry, yes or no? So if I want to calculate the area, what I can do? So I have divided this entire area into the small triangles. This is the triangulation approach. So do you remember what was the condition for the well-conditioned triangle and what was the condition for the ill-conditioned triangle? I hope you all remember that value. Whenever we will follow the triangulation approach, yes, any angle of this triangle should not be less than 30 degree, and any angle of this triangle should not be greater than 120 degree. If all the angles are in the range of 30 to 120 degree, we will say that triangle is the well-conditioned triangle. If any one of the angle of this triangle is not in this range, we will say that triangle is the ill-conditioned triangle. So let's say this is your first triangle. Let's say this is your first triangle. This is your second triangle. This is your third triangle, fourth triangle, fifth triangle, and sixth triangle. So now for this triangle, we can perform the linear measurement and angular measurement. I can measure all the sides of the triangle, and measurement of all the sides will be the linear measurement, and that we know how we can perform the linear measurement. Yes or no? How we can perform the linear measurement, that we already discussed. Similarly, we can measure all the angles also, and measurement of the angle is nothing but that is the angular measurement. Measurement of angle, we know how we can measure the horizontal angle. We know how we can measure the vertical angle. Various instruments are there, various methods are there. In short, I can say for this small triangle, I can measure all the sides, I can measure all the angles. Yes or no? I can measure all the sides, I can measure all the angles. Are you agreeing on this point, yes or no? Tell me. So, if you know all the sides, let's say A, B and C, if you know all the sides and all the angles, yes, if you know all the sides and all the angles of this triangle, so can I find out the area for any triangle? Yes or no? Can I find out the area of the triangle? And if we are adding all the triangular area, we will get the total area of this field. we will get the total area of this field, yes or no? Here you can ask one point. Sir, what about this area? Sir, I have one query. Okay, no problem. We have divided the entire area into the small triangles, and we have calculated the area of all the triangles. But what about this left area? Yes or no? Sir, in this calculation, you have not considered these portion. Yes, we have not considered. That's why we are saying this is the approximate method. How you can calculate more accurate area with the same approach? How you can calculate more accurate area with the same approach? So for that, we can define some more stations. We can increase the number of triangles. We can increase the number of triangles, yes or no? Exactly, we are not talking about the exact calculation. We are talking about the approximate calculation. And for irregular geometry, there are some methods from the help of those method, you can calculate the approximate area. So I hope by dividing the entire area into the number of triangles, how we can calculate the area, this point is clear to everyone. The total area will be equal to the summation of all the triangles area. Summation of all the triangles area, yes or no? That is the same thing that I have written here. Tell me in the chat box if the discussion about this method is clear to everyone. Or if anyone having any doubt, any query, then you can also ask your doubt. You can also ask your query, no problem with that. So what will be the approach in this method is clear to everyone. Please confirm in the chat box. Okay, very good. So now let's see some more methods. We want to improve the accuracy. So method 2 is by irregular offset method. So for example, as you can see, this was the area that we need to calculate. This was the area that we need to calculate. And to define this area, what we have done, we have considered some irregular offset like this. Why we have considered this irregular offset? First of all, why we are saying this is the irregular offset? Because the distance between all the offset is not same. So let's say this is the distance d1. So next distance is d2. If this d1 and d2 will be same, then we will say it is the regular offset method. If we are taking all the offset at regular interval, then we will say that is going to be the regular offset method. So here we have considered the irregular offset. First of all, first point was this. The second point, why we have considered the offset, why we have marked the offset for the calculation of the total area of this field, so that we will mark the offset, we will place the offset like this, so that we can divide the entire area into the small regular geometries. As we have considered this first offset, so let's say this is our offset 1 O1, this is your O2, and this is your O3. So as we have considered the offset 1, as you can see, now we are getting a regular geometry, that is the triangle. When we have considered the offset O3, as you can say, this is the trapezoidal. You can calculate the area of the trapezoid, yes or no? So now just with the help of these two offset O1 and O3, you can say the entire area is divided into the triangle area, trapezoid area, and again triangle area. And for these regular geometry, we know how we can calculate the area. If we know all the dimensions, all the angles, then we can easily calculate the area of the regular geometry, yes or no? So as per our suitability, we have considered some offset so that we can divide the entire area into the regular geometries. Here we are not just only focusing on the triangles. We want that our entire area should be divided into the regular geometry. Similarly, when I have considered this offset O2 on this left hand side, you can say this entire area is divided into the two triangles area. So now what I can write, total area of this field will be equal to A1 plus A2 plus A3 plus A4 plus A5 or up to AN. And all these area A1, A2, A3 are the area for the regular geometry. For the regular geometry. I hope the point is clear to everyone. Here we have not considered the offset at regular interval. That's why we are using the term irregular offset method. That's why we are using the term irregular offset method. What was the main objective? What was the main purpose of taking the offset? That so that we can get the regular geometry. So that we can get the regular geometry. That was the main point of concern. So in this way you can calculate the area. Obviously you can say the accuracy will be more as compared to the previous method. In the case of previous method, some area was left that we were not considering in our calculation, but in this you can say all the area we are calculating. So simply we want to improve the accuracy. For that we are discussing about the various methods. For that we are discussing about the various methods. I hope this point is clear to everyone. I hope this point is clear to everyone, yes or no? Everyone please confirm in the chat box how we can calculate the area by taking the irregular offset. By taking the irregular offset. Clear? Very good. So now there are some more methods. Now we will talk about the regular offset method. As we are saying, we are going to take the regular offset. That means, for example, this is your offset 1, this is your offset 2, this is your offset 3, this is your offset 4. What is the main important thing? For all the offset, the distance is same. So we have taken all the offset in regular interval, that is the D. We have considered all the offsets in the regular interval, that is the D. So what is the distance between the first and the second offset? That is the D. What is the distance between the second and third offset? Again the distance is D. What is the distance between the second and third offset? Again the distance is D. That's why we are saying this is the regular offset method. So whatever offset we have considered, all the offsets are at regular interval. All the offsets that we have considered are at regular interval. Let's try to understand the approach. In the regular offset method, first we are discussing about the average offset method. So simply we know area. Simply we know area. For area we require 2 dimension. For area we require 2 dimension. Yes or no? So if I know this total distance L, let's say if I know this total distance L, and for that what now I am taking, I am considering the average height of the offset. I am considering the average height, H average, or average dimension of the offset, that is going to be H average. Yes or no? Yes or no? If we take the average of all the offset, we will get H average. Sir, how we can take the H average? So H average will be nothing but, dear, this is going to be H1 plus H2 plus H3 so on plus Hn by n. Yes or no? So if I am going to multiply L with H average, can I get the area? Can I get the area, yes or no? But again, this is not going to be 100% accurate method, because all the offset were not having the dimension that was equal to H average. Some offset were greater than from the H average, some offset were less than from the H average, but approximate area you can calculate in this way. Yes or no? But approximate area you can calculate in this way. So this is your average offset method of the regular offset. Any doubt to anyone? So simply we can say total area will be equal to total length into average offset. And total length we can calculate n minus 1 into d, because we know what is the distance between the two offset. Because we know what is the distance between the two offset. I hope this point is clear to everyone. I hope this method is clear to everyone, yes or no? Just confirm one by one. We will cover all the basic concepts of all the methods one by one. You just need to confirm in the chat box if the entire discussion is clear to everyone. Can we move further? Can we move further? So in the case of regular offset only, we are discussing some more method so that we can calculate more accurate value of the area. Until now, all the methods that we have covered are related how we can calculate the area. Similarly, we will see some methods related to the calculation of the volume. Don't worry. So can we move further? Can we move further? Yes or no? Okay, so now let's see the further discussion. Now we are discussing the second method, and this method is important from your exam point of view. These two methods are important. This is the trapezoidal method, and then we will discuss about the Simpson's method. These two methods are, you will get the question in your exam from these two methods only. Trapezoidal method and Simpson's method. This is also a method of regular offset method. Again, this D is fixed. All the offsets that we have taken at a regular interval. Now what we are doing? So for example, this is your offset. So we are calculating this area. Again, if we talk about the area between these two offset, so for that we are calculating this area. Something like this. Now we are calculating this area. Let's try to understand the approach. Obviously, here you can see the calculations that we are performing. On that basis, we can calculate the most accurate area as compared to the previous method. Yes or no? So what will be the formula that we can use directly? Area total will be equal to D, and this is H1 plus Hn by 2, and this is going to be plus remaining offset H2 plus H3 plus H4. So let's say this is going to be your H1, this is your nth offset. So we can calculate area total will be equal to D. First and last offset, so this is going to be H1 plus Hn by 2, and then the remaining offset. So this is going to be H2 plus H3, so on, plus Hn minus 1, something like this. So obviously, if I talk about the trapezoidal method, it will be more accurate as compared to the previous method, that was the average offset method. Point is clear to everyone? Yes or no? Okay, now discussion is clear. And the most important, or you can say the most accurate method is for the calculation of area for the irregular shape is going to be the Simpson's rule or Prismidal rule. Sir, in the question, how do I know that from which method we need to calculate the area? So don't worry for that. In the question, they will provide you the method. They will specify you the method. Ki from this method, from trapezoidal method or from the Simpson's method, you need to calculate the area. Sir, what data they will provide? In the question, sir, what data they will provide? So they will provide you the detail of all the offset. How many offsets are there? What are the dimension of the offsets? What is the interval between the offset? So they will provide you all the necessary condition. Like they will provide you H1, H2, H3, H4, Hn. They will provide you the value of small d. What is the interval? So if you know the d, if you know all the offsets, so we can very easily calculate the area. For example, till now we have discussed about the trapezoidal method, yes or no? So what we will do? We will simply use this formula d h1 first and last log offset by 2 and the remaining offset. Summation of all the offset. Yes or no? Yes or no? So you just need to put all the value, you will get the answer. You just need to put all the values and you are going to get the correct answer. Similarly, if I talk about the Simpson's method, again this method is also valid for regular offset method. Here also we are considering all the offsets in regular interval. Here also we are considering all the offsets in regular interval, that is the d. So what will be the formula in this case? So this is going to be the formula, and I will suggest do remember formula only. We will directly apply the formula to get the answer. So this is going to be d by 3 first and last offset summation plus 4 multiply में है and there is summation of even offset and 2 summation of odd offset. So first and last 4 even plus 2 odd. 2 odd. So this is the method, this is the formula that we can use for the calculation of the area with the help of the Simpson's method. But you need to remember some important things related to the application of this formula. What are those important things? Like Simpson's rule is applicable for odd number of offset. So for example, there are 7 offset, there are 5 offset, there are 9 offset. You can directly apply this formula, no problem with that. Simpson's method, Simpson's formula for the calculating the area is valid for the odd number of offset. But it is not mandatory or it is not compulsory that in the question they will always provide you odd number of offset. So let's say for example, sir, in the question, for example, let's say in the question, for example, they have provided number of offsets were, like number of offsets are 8. So can you apply the Simpson's method for this number of offset? For even number of offset, can you apply the Simpson's method for the calculation of area and for the calculation of volume? No, because Simpson's method is applicable only for odd number of offset. Odd number of offset. Or let's say in the question they have provided you the total offset that are even and they have asked the area. They have asked the area by Simpson's method. They have asked the area by Simpson's method. In that case, what you will do? The total number of offsets are given in the questions are even offset, but they are asking the area from the Simpson's method. And as we know, the Simpson's method is applicable only for the odd number of offset. In that case, what should be our approach to get the area? So that is approach is written here. So in this case, what we will do to work with the even number of offset. To work with the even number of offset, Simpson's method should be applied up to the last odd offset, up to the up to the last odd offset, and the remaining area we can calculate with the help of the trapezoidal method. Sir, please explain this point. Sir, please explain this point in more detail. Don't worry, let's see. So for this case, we will calculate the area from offset number 1 to 7 with the area total will be equal to. So this area we can calculate with the help of the Simpsons. Yes or no? This area from the offset 1 to offset 7 we can calculate with the help of the Simpsons method. Yes or no? Because 7 is an odd number, and for odd number of offset we can apply the Simpsons method. So what is the remaining area? What will be the remaining area? So the remaining area, sir, will be from the 7 offset to 8 offset. Yes or no? That is going to be the left or remaining area. That is going to be the left or remaining area. Area from offset number 7 to the offset number 8. Till 7 number offset, we have calculated the area with the help of Simpsons method. And last remaining area, we have calculated with the help of the trapezoidal method. We have calculated with the help of the trapezoidal method. So in this way, we can calculate the total area. In this way, we can calculate the total area. In this way, we can calculate the total area. Do you have any problem on this? So whenever you will see the problem related to the Simpsons, whenever you will see the problem related to the Simpsons, make sure you are going to apply this Simpsons formula only for the odd number of the offset. Only for the odd number of the offset. So everyone please confirm the discussion till now, how we can calculate the area from the various method is clear to everyone. Which method is the most accurate method? Which method is the most accurate method for the calculation of the area? Which method? Various methods we have discussed. Which method is more accurate method for the calculation of the area? Obviously, the answer is going to be Simpsons method. Obviously, the answer will be Simpsons method. Please confirm in the chat box if the discussion till now is clear to everyone. I am unable to see your comments, beta. I am unable to see your comments. Make sure all the comments are visible. You are connected. Make sure to do comment in the chat box. The discussion till now is clear to everyone. Yes or no? So I hope the discussion till now is clear to everyone. So in this way, we have completed our discussion for the calculation of the area. In this way, we have completed our discussion for the calculation of the area. Now what we want to do? Now we want to calculate the volume. So as we have just discussed, we can simply write volume will be equal to area into third dimension. Area into third dimension. Yes or no? Or simply we can write volume will be equal to L into B into H. L into B is nothing but area. Yes or no? So just try to visualize in 3D. just try to visualize a 3D situation. So for example, there is a body like this. Just try to visualize in 3D. So you must have seen some feeling like this, and this is known as the embankment. This is known as the embankment. I hope you all can visualize. Yes or no? I hope you all can visualize. Or you can remove this part. So now our concern is to find out the volume. Now our concern is to find out the volume. How we can find out the volume? How we can find out the volume for this embankment or for this filling? For this embankment or for this filling. So now what I can do, I can simply take some offsets, something like this. So let's say this is the area A1. Let's say this is the area A1. If anyhow I can calculate the, and if we know this dimension, let's say this dimension is D. So for this reason, can I calculate the volume very easily? This is going to be area into D. Yes or no? Tell me. Similarly, here also if I can find out the, this area, this hashed area, again this area into D will be equal to the remaining volume, and simply we can add these two volumes to get the exact volume. Yes or no? Yes or no? If uniform height is there, we can calculate this volume in a single step. If this depth is not varying, this is the leveled surface, we can calculate the volume in a single step. Area into third dimension. Area into third dimension is going to be the volume. Area into the third dimension will be equal to the volume. I hope basic of the calculation of the volume is clear to everyone. So it is very easy to calculate the volume also for the irregular shape. Again, same discussion is valid. Again, same discussion is valid. If you have regular geometry, then you don't have any problem for the calculation of area and volume. Why we are discussing about the trapezoidal method? Why we are discussing about the Simpson's method? Because from these methods, you can calculate the area and volume for the irregular geometry. For the irregular geometry. So, we will calculate the volume with the help of the two methods. One is the trapezoidal method and one is the Simpson's method. When I am talking about the volume, obviously you have to visualize the situation in 3 dimensions. Yes or no? When I was talking about the area, you was visualizing the situation in 2 dimensions. You was visualizing the situation in 2 dimensions only. Yes or no? So that you can easily visualize the situation in 3 dimensions, I have considered this example. I have considered this example. So can we move further? Can we move further, dear? Yes or no? Can we move further? So now we will see how we can calculate the volume with the help of the trapezoidal method and with the help of the Simpson's method. Same formula with little change. That formula we have discussed for 2D. Now we have to add one more dimension. Now we have to add one more dimension. So let's say, first we are discussing about the trapezoidal method. First we are discussing about the trapezoidal method. Very easy and very simple. Very easy and very simple. So volume total will be equal to D A1 plus first and last area by 2. So for example, this was your first area and this was your second area. This was your second area of this phase 2 A2 and so on. A3 may be there, A4 may be there. So what I can write here? Can I write the total volume will be equal to D first and last by 2 plus A2 plus A3 plus A4. This is the same formula, same type of the formula you can say, which we have used for the calculation of the area. Which we have used for the calculation of the area, yes or no? So if I talk about the area from the trapezoidal method, so area total will be equal to D. Here we have used first and last offset by 2 plus remaining offset. Yes or no? So this is for the area and this is for the volume. We have just simply replaced offset with the area because area into third dimension will be equal to the volume. Area into the third dimension will be equal to the volume. Any doubt to anyone? Any doubt to anyone? Any doubt to anyone? So if anyone is having any doubt, you can ask your doubt, dear. No, all the points are clear. Very good. Similarly, dear, if I talk about how we can calculate the volume with the help of the Simpson's or Prismoidal rule, same concept. Same concept. D by 3, first and last area, 4 even area, 2 odd area. Same we have discussed for the calculation of total area. So will be equal to D by 3. This was first and last H1 and Hn plus 4, H2 plus H4 plus H6 and so on plus 2. This is going to be H3 plus H5 plus H7 and so on. So this that we have discussed for the area, and this here we are considering the volume. Only these 4 formulas are important from your GATE exam point of view. Calculation of area and volume. If I conclude this chapter, I am concluding this discussion, only these 4 formulas are important. You will get direct formula based problem from this chapter. So you should know how we can calculate the area, how we can calculate the volume with the help of the trapezoidal method and with the help of the Simpson's method. So this was the conceptual part related to the calculation of area and volume that you should know in this chapter. So let's summarize in this course. What are the various chapters that we have completed till now and what will be the next discussion? What will be the next discussion? So some questions we have discussed. I have discussed in the class how they are asking the question from the particular topic. In all the chapters, I have told you the variety of the questions that they are asking in the exam. Yes or no? From the beginning itself, in all the chapters we have discussed which type of the question or from a particular topic, which question they can ask. And you are also practicing the PYQs. So you are also able to solve the question, yes or no? You are also able to solve the DPP's question, but some good questions from all the topics are there. That should be discussed in the class itself. Yes or no? That should be discussed in the class itself. So let's see how we are going to proceed further. So if I talk about the chapters in this course, so fundamental of surveying, second chapter we have discussed, that was the linear measurement. Third chapter was compass surveying. Third chapter was compass surveying. Fourth chapter was traverse surveying. Fifth chapter was labeling. Sixth chapter that we have discussed, that was the contour. Seventh chapter was trigonometrical labeling. Trigonometrical labeling. Eighth chapter was theodolite. Next chapter was tachyometry. And the next chapter we have covered, that was the plane table survey. Plane table survey. And just we have calculated calculation of area and volume. Calculation of area and volume. So these are the 11 chapters that we have covered. These are the 11 chapters that we have covered, yes or no? Trigonometrical labeling that I have mentioned. These are the 11 chapters that we have covered in this course till now. So now what, two more chapters are there in the basic surveying, like curves की बात करेंगे, we will talk about the curves and we will talk about the accuracy and error. Then we will talk about the photogrammetry survey. These are the remaining part, and basics of the GPS, GIS and remote sensing. So what we are going to do tomorrow, this is very important. So what I will do, I will take PYQs of GATE and ESE. So kal in both classes we will complete the two topics. Triangulation we have just discussed in basic, so that you can consider, yes or no. In triangulation we have only discussed a condition, that's it, yes or no. So tomorrow we are going to practice 20 best PYQ. 20 best PYQ from all these chapters. So you have one more chance. What you can do, you can revise all these chapters. You can revise all these chapters so that if you have any doubt, any query at any point, you can ask your doubts and queries in the tomorrow's class. Dear satellite station signal, some topics are there. I am not saying we have completed the discussion for the surveying. So what are the remaining topics that you can also see? So, we will talk about the theories of error. Tomorrow we will talk about the theory of error. We will talk about the curves. We will talk about the photogrammetry survey. We will talk about the photogrammetry survey. We will talk about the basics of GPS, GIS and remote sensing. These are the left topic, don't worry. These are the topics that we will also cover. So these two topics we will cover tomorrow. These two topics we will cover tomorrow, and with this we will also practice 20 best PYQs. 20 best PYQs from all these 11 chapters, so that we can summarize all our discussion. So we have, from our syllabus point of view, if you remember, I have classified the surveying in two ways. First was the discussion related to the basic surveying. So tomorrow we are going to complete our discussion for the basic surveying. Then the left discussion will be related to, this is the discussion related to your modern surveying. This is the discussion related to your modern surveying. So tomorrow we will complete the tomorrow we will complete the discussion for the basic surveying, or we will also complete some good question discussion in the class itself, apart from your DPP, so that you can revise all the chapters, all the concepts, and If you have missed any concept, any chapter, so you can clearly understand which type of the question they are asking in your exam. So that will be the tomorrow's discussion, 20 question discussion. But I want you should be ready for that. This session I am planning just for you. This question I am considering just for all of you. So if you will not able to solve the question, and when you will not able to solve the question, when you will attend the class without proper revision. Yes or no? So what I am expecting from all of you, you have sufficient time. Try to revise all these chapters thoroughly. Try to revise all these chapters thoroughly, so that when we will have the discussion for the question, you can easily attempt that question, or at least you can understand that question what they are asking. If you don't know the concept, then there will be no interaction. Yes or no? So try to make tomorrow's session very fruitful. I have planned my best so that I can revise all the concepts. That's why I have added PYQ discussion separately. Yes. So this will be the approach. And yes, we are going to complete this course on 19th of Feb. Don't worry. So 19th of Feb will be the last class, and from 20th of Feb, your next subject will start. So make sure before attending the tomorrow's class, you have revised all the discussion till the chapter number 11. So I hope you all will revise. Yes or no? I hope you all will revise all these concepts. Okay, very good. So this was all about for today's class. This was the discussion. We will meet tomorrow for the further discussion. Thank you everyone. Keep learning better. Thank you.